let us look at a couple of examples with small sample sizes and sigma is unknown. So in this is an example we did before. So in this example the sigma value was given. So at the time this part E, if sigma is unknown, can you give a 95% confidence interval for mu? At that time we said that we are going to look at it. Now you already know what we are, how to take care of it. So basically what happened is that we replace the sigma value by the S value, and then we'll end up with using the T table value. Okay, so let us look at that. So it's pretty much all you have to do is that use the T table value instead of the Z table value. So that problem, so here n equal 3, those two x bar and s. So here x bar value and the T table, this is the value that is coming out of with degrees of freedom 2, n minus 1, 3 minus 1. So and from the T table, look for that value, leaving 0.025 to this side and to that 0.025 to this side and 95% in the middle. So that is 4.303. So that is the T table value and the S value divided by square root of 3. All right, so then this is the interval basically. So when you calculate that, this is going to go from here to here. So this is the 95% interval. So here what you need is that initial distribution got to be a normal one. In this question that is given. All right, so well, if it is not given, so you don't know any other way, so this is the only way you know, but you have to assume that the initial distribution is a normal distribution if it is not given, but in this case that is given anyway. Okay, all right, so so as far as the interpretation goes, it's just the same as before. So if you keep picking samples like this over and over, 95% of the time the unknown mu value within the margins you are going to get. All right, so but you do this way only if you do not know the sigma value. Otherwise you're supposed to do it the way we did before. Okay, we are not supposed to do it that way because you never use an estimate for the sigma. All right, so let us look at these three examples very quick. They are pretty much the same way. Okay, so here there are 5 values. So you want to construct 90% confidence interval. So punch those values into the memory and figure out the sample mean and the sample standard deviation. And what you need to watch out is that, so it says that the distribution, assume a normal distribution. So we have no issue. Okay. So otherwise, if this part is not given, you will get the answer. But at the end, you need to say that validity of your answer depend on that normal assumption. Okay, so all right, so here the degrees of freedom is going to be 4, 5 minus 1. So the degrees of freedom is going to be 4. So get the T table value. So that is going to be 2.132 with 90%. So the x bar minus the T table value, S value divided by square root of n. So calculate that. That is your interval. Okay. So as I said before, if normality is not given, you need to pretty much, if that is not given, actually you need to check it if you are doing, if you have the values. But in the exam, of course, you cannot check it because you cannot check that normal quantile plot. So then you just say that the answer depends on that assumption. But if you have to check whether this data is coming from the normal distribution, you could use those normal quantile plot we were looking at in the beginning. So kind of they're supposed to stay on a straight line. Okay, so things like that. There are graphical methods. You can use one of those methods. Okay, but pretty much the distribution has to be a normal curve. Okay. All right. So this question. So sample size is 16, and you have this the mean and the variance is given. So you want to find the confidence interval. But in the so it also says that it's normally distributed. All right, since this is normally distributed, so you have the assumption, so that question is exactly the same way. The t automatically is the t, so that get this value from the t table with 98 with the degrees of freedom 16. So here you get the interval. Okay, so in this question actually kind of you cannot check the normality because you don't have the data. Not like this question. This question you could check the normality kind of using this one of those graphical methods. Here there's nothing you can do other than, if that is not given, other than saying that the data has to come from a normal distribution. Okay, all right, if that is not given. So for this question, see this one, so you have a bunch of data. Of course you can figure these two out, so you figure this thing out 90%. So it's a must that you are going to use the t. Okay, so because sigma is not given in the question, so pretty much that is the answer. Okay, so the degrees of freedom is 11. Find the t table value, so get that, then you can do it. Okay, so need to check the normality. Since you have the data, you can go and check the normality whether it's a reasonable assumption because you have the data. But if you are doing this kind of problem in the exam, you can say that the assumption is that the data should come from a normal distribution. All right, so the last example, see the thing is that this one, if you look at this question, which method you are going to use, so certainly you can figure out the x bar and the s. All right, so here see this part, sigma is given, therefore you are not supposed to use the t. All right, so you're supposed to use the z because you are not supposed to use this value for that. So in other words, going to go back to the original things we did. Okay, so you're not supposed to use the t distribution at all for this thing. Okay, so it's got to be you're using only this value actually. But at the meantime, this must be a normal because this is a small sample. So if that is not given, this part, you need to say that the data has to come from a normal. But you cannot use the t. That's the point. Okay, you cannot use the t. So that must use the z interval. So in other words, with 98, the z table value is going to be 2.33. All right, so figure out the interval the way we did right in the beginning of this chapter. All right, so that's about this. Okay.